Following on from the previous video, we're now going to graph velocity. So I can see which is the velocity column here, and I can copy up to the top. I want to insert a simple line graph. All this stuff can be jazzed up later on if you want to. Now again, I'm going to do my trick to convert this bottom axis to time. I didn't figure out how to put a label on it, but that can be done later. So right click, let's select the data, let's edit this, copy the address here, cancel, pick out our date. There's probably a better way to do this, but I don't know it. We want time. Time is in column B, so I'm going to go B and B. OK, and we are now dealing in the same time that we've got in the graph above. Now at the moment this graph doesn't look too pronounced. We're talking velocity. How come most of our velocity is negative? That looks pretty dodgy. Let me just run down and see what's going on. Distances, velocities are negative. I wonder what I've done. Let me just check my formula here before we go any further. Oh, not, yeah, formula here. E10 minus E11. That should be right. That's the previous position minus the current position. Are all of those? Yeah, see here my all my velocities. Maybe. Let's reverse that. Sorry, bit of an error there. Velocity. Oh, let's go down. Here's velocity. Let's do this position minus the previous position. So equals here minus here. Okay, that'll stuff up our acceleration as well. Alright, let's copy that down. While I'm at it, I should fix the acceleration, and then the averages will be okay. The acceleration here should be F4 minus F3. Oops, a little bit of a muddle up here. Lucky we could see the graph and see that that's the case. Alright, here, velocity, acceleration. Let's fix that. Let's watch the graph change. Okay, and run up to the top. Well, actually, while I'm running up to the top, yeah, I've got the graph there. Okay, and now, oh, my graph is still the same. Yeah, no, here we go. Took a little while. That's better. We are getting we're stationary for a while. We are getting a positive velocity up here, and then we are slowing down. Our deceleration is faster than our acceleration. Now I'm just going to change my axes here because, so I double clicked on my axis. I don't want these spikes. They're errors. They're mucking around while I was in the shade there. So let's go to a maximum of 0.15. 1.5, and let's go to our minimum. Really our velocity is never going to be negative, so our minimum can be 0, and see what difference that makes. I'm tabbing out of that. Whoa, didn't like that. I want plus 0.15. Oh, that's the minimum. Oh, let's do this again. 0, tab, and I want plus 1.5. That's a bit better. Okay, tab. That's a bit better. Now, so we've got a respectable looking velocity graph there. Okay, now acceleration. We're going to do our tracked acceleration, our trailing average acceleration, and even here you're going to see that it is pretty erratic. By the way, we can't do all these on the same graph because they have such different scales. Okay, you can see that it's erratic, particularly at the beginning. So let's go down here underneath our velocity. Let's make it a bit wider. We have to do our little trick with the time axis. Select the data, edit, grab this, copy, cancel, edit, paste, and our time data is in column B. It'll convert that up to uppercase itself. Alright, okay. So we've got this. Let's get rid of all of this erratic stuff, which was at the beginning when my head was bobbing around one way or the other. So it looks like the maximum here is 0.02. Let's double click on this again. Go over here, and we want the axis options. Let's get it right this time. The minimum is going to be minus 0.002, minus 0.002, and the maximum is going to be 0.002, I would say. 2. It doesn't matter that those ones are going off the scale. We could do that 0.002, 0.0015 we could do. 15 tab. Whoa, what happened then? Maximum Control Z. What did I do? Control Z. 0.015. 0.0015 must have been 0015 tab. That's better. All right. This is looking promising. So what we can see now is that as we started our motion, our acceleration was fairly high, particularly in this stretch here. We are accelerating quite a bit. Up as we're approaching maximum speed, our acceleration is dropping off. Here our acceleration is 0, and that's really corresponding with the maximum point up here, which is what our calculus should tell us. And then we decelerate quite fast, and so the deceleration here is actually greater. It's bigger than its magnitude is greater than 0.002. We've got nothing here near 0.002, so our deceleration is at a greater rate than our acceleration. So I think we've finally finished our project of graphing. Let me back this off a little bit. We'll get rid of our menu bar for a moment and have a look at those 3 graphs underneath one another, all taken from the same video clip. We are moving from 0 to 20 meters. We are increasing our velocity, then decreasing our velocity, and we're stationary at the end and stationary at the start. We are accelerating hard, then we have 0 acceleration at our maximum speed, and then we are decelerating hard. Okay, thanks for watching this series of videos. It's pretty technical, but all doable.